Okay, so we're going to go ahead and get started with talking about discontinuities. Now, you've encountered a couple of these in doing some of your limits and continuity practice. So, if something isn't continuous, that means it has a discontinuity. Now, there's a couple different types that you might have encountered so far. And the first one is called a jump. Now, a jump, in formal definition, if we're getting fancy, is where the limit as x approaches a from the left is equal to some value L, and the limit as x approaches a from the right is equal to some value k, where L does not equal k. Now, that's just a really fancy way of saying that when you take the limit from each side, they're not equal. Meaning that if I were going to draw a picture here in blue, oops, if I were going to draw a picture here in blue, it might look something like this, meaning that from one side it goes towards one value, and then from the other side it goes to a different value. That is called a jump, meaning that if I were a little roller coaster man here in yellow, I'd be running up the hill, a lot, and then I have to jump down and run back up the hill again. So there's a jump there. Now, typically, when you see these in function form, it's usually written as a piecewise function. Now, sometimes a piecewise function is continuous, but other times it is not. So it might look something like this. If I plugged in 2, then the y value for the top one would be 2. And if I plug in 2 for the bottom one, it becomes 1, meaning that when I plug in on one side, it's 2, and on the other side, it's 1. So that would be a jump. It's not the same from both sides of the equation. So that's the first type. The next type is called an infinite discontinuity. Now, an infinite discontinuity is where you have the limit as x approaches a from the left or from the right, or from both sides, is going to go towards positive or negative infinity, hence the name infinite. Now, if I were going to have a picture of this one, it might look something like this. We graph it with that imaginary vertical asymptote. So if an equation has a vertical asymptote, then it has an infinite discontinuity, meaning it's just this big wide line that I can never get from here to here. Okay, and then lastly, so an example is if you have an equation like this, 3x minus 1 over x plus 5. It might look something like that. It's usually a rational function. There are a couple other exceptions as well, but this is just one example of an infinite discontinuity. Now, the next one we have is removable. Now, a removable discontinuity has a couple different names, but the one that is most common, or the second most common, is called a hole. So this is where the limit as x approaches a from the left and as x approaches a from the right are both equal to the same number, but when you plug in the actual number, it does not equal that same limit. So in a picture, it looks something on a graph, it looks something like this. Meaning there's a hole there. Sometimes the value will be completely different. Sometimes the value will not exist. But that is what it looks like. Now, for as far as a function, what it might look like is also typically a piecewise function, but not always. So I could have negative x plus 3 and negative x squared plus 3, where x is less than 1 and x is greater than 1. And the differences here is that none of these have the equal sign, meaning there is not a function value for 1, or if it had something like this where it says that the function at x equals 1 is 746. Like clearly that is not where the function is supposed to go, because when you plug in 1, you should get 2, not 746. Okay, and lastly, not lastly, but the last type, I guess, we have is endpoints. So for endpoints, it's where there is a domain restriction. So here is a graph of the square root of x, and you cannot take the square root of a negative number unless you're working with imaginary groups. So square root of x has an endpoint discontinuity, meaning it can't keep going this way. And then, of course, mixed is some combination of these. So sometimes I might have a graph that has multiple types. So it could look something like this. There could be an infinite discontinuity here, but maybe there's also a hole here. So that's called mixed. So that's discontinuities. I think it's pretty straightforward.